Hi, today we are going to discuss vectors, vector algebra. Okay. We have to locate a point in a plane, we need x-axis and y-axis. But to locate a point in a space, we need three axes, x-axis, y-axis and z-axis. Look here. Here P is a point and its coordinate is x, y, z. Okay, it is x, y, z is the point P. Okay, then its y coordinate is here, x coordinate is here in red line, that is Px. All red lines are equal. This red line, all red lines are equal because all these are the edges of the same cuboid. Similarly, all green lines are equal, which is the y coordinate of the point P. Why they are equal? Because they are the equal edges of cuboid. Similarly, all green lines are equal and is the z coordinate of the point P. This is how we can express a point. We can locate a point in a space. Okay. Then move forward. We have in a plane there is 4 quadrants. First quadrant, second quadrant, and third quadrant, fourth quadrant. Okay, each quadrant have different signs for x and y. Here x is positive, y is also positive. Here x is negative, y is positive. Here x negative and y is also negative. Here x is positive but y is negative. Okay, we have we already know it. Okay, but what about space? These 3 reference lines, that is x-axis, y-axis and z-axis, divide the total space into 8 equal spaces, and these equal spaces are said to be octants. Okay, look here. Here first octant, second octant, third octant, fourth octant, and back side there is 4, and total 8 octants are there. Okay, and each octant similar way as we are expressed in plane. Similarly, different coordinate have different x coordinate and y coordinate, z coordinate have different signs in different octants. Okay, that we can check it. Okay, here you can see this is first octant. All the coordinates, x coordinate, y coordinate and z coordinate are positive. And what about in seventh octant? Seventh octant, all coordinates x, y, z are negative. Okay, then there is a table. You have to write it down. Okay. Each octant have different signs for x coordinate, y coordinate and z coordinate. Okay. Okay. Then what is vector? Vector is a quantity which has both magnitude and direction. Scalar is a quantity which has only magnitude. What actually it mean by? I am taking two here. Some of the quantities are listed and scalar quantities as vector quantities. Okay, then I am taking mass from scalar quantities and weight from vector quantity. Okay, what is the difference between mass and weight? What is mass? Mass is the content of the matter. Okay, when we goes to moon, there is no change for mass. Okay, but if we goes to moon, there is no weight. Okay, why there is no weight? Because there is no gravitational force. So gravitational force actually which provide direction to weight. Okay, and so it has both direction and magnitude. But mass is the content of matter. It has no change and it has no direction when we goes to moon. Similarly, and it has no mass has no direction, and so it is scalar quantity. Mass is a scalar quantity, but weight is a vector quantity. Okay, that is the difference between scalar quantity and vector quantity. Okay, vector quantity has both magnitude and direction, but scalar has only magnitude. Okay. Then we are going to discuss vectors. Look here, a vector is represented by an arrow. Okay, let this is we can represent it is vector A, and the arrow to which direction the arrow pointed is the direction of that vector. Okay, similarly the length of it is said to be magnitude of vector. Okay, that is the magnitude and direction of the vector, and we represent the vector using an arrow. Okay. And here 3 points A and B and C. Okay, 3 points are there. Then what about the point A? It is a point on x-axis. So in 2D we have already studied the point on the x-axis. What happened to y coordinate? Y coordinate is 0. The point on the y-axis, then x coordinate is 0. Similarly, if we have A is a point on x-axis, so its x coordinate is there, y coordinate and z coordinate is 0. And this length, that is, this is origin, we have, this is origin, and let this is A, then OA, the length of OA is 1 unit. Let the length of OA is 1 unit, then this point is 1, 0, 0. Okay, this point is 1, 0, 0, because x coordinate is 1, because the point A is 1 unit from origin. Okay. Similarly, what about its y coordinate and z coordinate? They are 0 because the point is on x-axis. Similarly, the point on y-axis is 0, 1, 0 because x coordinate and y coordinates are 0 in case if the point is on y-axis. Okay. Similarly, 0, 0, 1 is the point on z-axis, and we can call it as C. This is A and this is B. Okay. Then OB vector has magnitude. OB has magnitude 1 unit. OC has also magnitude 1 unit. Okay. Then what about OA vector? OA vector is the vector along the direction of x-axis. And what about its magnitude? Its magnitude is 1. Okay, so we can represent this, we can call this vector as I. That is, I is a unit vector along the direction of x-axis. Similarly, there is a point B. It is 1 unit distance from it is 1 unit distance from origin. Okay. Then OB vector, magnitude of OB vector is 1 because OB, the length of OB is 1. Okay. Then what about its direction? It is along the direction of y-axis. So J cap is the vector. This is I cap. Then J cap is the vector. It is unit vector along the direction of y-axis. Similarly, K cap is the unit vector which is equal to OC. Here it is C, OC vector, and its magnitude is 1, and its direction is along z-axis. So K is the unit vector along the direction of z-axis. Okay. ഈ കാര്യങ്ങൾ മനസ്സിലായല്ലോ. അപ്പോൾ I is the unit vector along the direction of x-axis, J is the unit vector along the direction of y-axis, K is the unit vector along the direction of z-axis. Okay. Then we have F, this is origin. Let this is a point P, x, y, z. Then OP is known as, OP vector is known as position vector. We will study later in detail position vector. Why it is called position vector? Because it locates this point P with respect to origin. Okay. What is position vector? Position vector is a fixed vector which locates a point with respect to another point. Usually it is origin. Okay, so here OP is a position vector. It locates the point P with respect to origin. That is why this vector is said to be position vector. Let OP made an angle alpha with a positive direction of x-axis. Let beta is the angle made by positive direction of y-axis by OP, and gamma is the angle made by the OP with a positive direction of z-axis. Okay, then these angles are said to be, that is alpha, beta, gamma. These angles alpha, beta, gamma, and these angles are said to be direction angles. Direction angles. Okay, we will study in 3D in detail. Cos alpha, cos beta, cos gamma are said to be direction cosines. Why they are called direction cosines? Because they are the cosines of the direction angles alpha, beta, gamma, where alpha, beta, gamma are the angles made by the position vector OP with the positive direction of x-axis, positive direction of y-axis, and positive direction of z-axis respectively. Okay, okay, then we can go forward. Here a question. Lambda I 2 lambda j plus 2 lambda k is a unit vector. Then the value of lambda is, we know that if the magnitude of vector is 1, then it is unit vector. Okay, then here this vector is a unit vector. Then we have to find the value of lambda. So how can we find the magnitude of a vector? Let this is a vector is equal to xi plus yj plus zk is a vector. Okay, then x and y z are the scalar components of I, j, k respectively. Then what is magnitude of A? Magnitude of A is equal to root of x square plus y square plus z square. Okay, we can prove it. Okay, then here let this vector is A equal to lambda I plus 2 lambda j plus 2 lambda k. Okay, this is vector A. Then what is magnitude of vector A? Magnitude of vector A is equal to root of, then scalar component of x I cap is here lambda. Okay, then lambda square plus the scalar component of j is 2 lambda, then 2 lambda whole square plus 2 lambda whole square, which is given 1. It is unit vector. Okay, then root of lambda square plus 4 lambda square plus 4 lambda square is equal to 4 plus 4 8 root of 9 lambda square, which is equal to 3 lambda. It is given 1. Okay, then what is lambda? Lambda is equal to 1 by 3. Lambda is 1 by 3. Option 2 is correct. Okay, we can find magnitude of vector in this way. Okay, then what is unit vector along the direction of a vector? Let A is a vector. Okay, then the unit vector along the direction of the vector A is given by, that is A cap, which is unit vector, and we can use the cap, which means A is a unit vector. Okay, then A cap is equal to vector A divided by magnitude of vector A. Okay, vector A divided by magnitude of vector A. This is the unit vector along the direction of the given vector A. Okay, then what is magnitude of A cap? Magnitude of A cap is equal to 1. Magnitude of A cap is equal to 1. Okay. Then there is a question. A equal to 2i plus 5j, B is equal to 2i minus j. Then the unit vector along the direction of A plus B. Okay, unit vector along the direction of A magnitude ആവശ്യമില്ല. Okay, unit vector along the direction of A plus B. Okay, then first we have to find A plus B. How can we find A plus B? Adding two vectors. Adding two vectors is nothing, adding scalar components. Okay, that is A is we have A equal to 2I plus 5j. Okay, and B is equal to we have 2I minus j. Okay, then A plus B is equal to 2 plus 2 4I 5j minus j plus 4j. Okay, 5j plus minus j 4j. Okay, then how can we find the unit vector along the direction of this vector? We have to find the magnitude of A plus B, and we have to divide the A plus B with the magnitude of A plus B. Okay, how can we find the magnitude of A plus B? One second. A plus B, magnitude of A plus B is equal to root of A plus B is given 4I plus 4j. Then what is magnitude of A plus B? 4 square plus 4 square. That is root of 16 plus 16, which is equal to root of 32, and we can write 16 into 2, which is 32. Okay, then 16, root of 16 is 4, then we got 4 root 2. 4 root 2 is A plus B. Then what is unit vector along the direction of A plus B? Unit vector along the direction of A plus B, that is A plus B cap. Okay, A plus B cap, that is unit vector along the direction of A plus B, which is given by A plus B divided by magnitude of A plus B. Okay, what is A plus B? A plus B 4I plus 4j. 4I plus 4j, we can divide this vector with the magnitude of the vector, and magnitude of the vector is given by 4 root 2. Okay, then take 4 outside, 4 into I plus j divided by 4 root 2. We can cancel 4, then 1 by root 2 into I plus j is the vector, unit vector along the direction of A plus B. Okay, then 1 by root 2 into I plus j. Fourth option is correct. Okay, I think you got it. Yes. Okay, let this is a point P, this is a point P, and its coordinate is x, y, z. Okay, then we have yj is a vector having magnitude y along the direction of y axis, and xi is a vector which has the magnitude x along the direction of x axis. Similarly, set k we have is a vector having magnitude z along the direction of z axis. Okay, then we have to find the position vector OP. This is O and this is P, and OP is the position vector. Okay, why it is position vector? Because it locates the point P with respect to origin. That is why OP is a position vector. So we have the coordinate of the point P is x, y, z. Okay, let this is A, B, C. Let a person moves from A to B. Okay, let this is A, and this is vector B. This is vector R. Let a person moves from A to B. Okay, then moves from B to C. What is the actual displacement? What is the actual displacement? Yes, actual displacement from A to C. Okay, actual displacement from A to C. Then we can write it as vector A plus vector B is equal to vector R. A person moves from A to B, then moves from B to C, then actual displacement is from A to C. That is vector A plus vector B is equal to vector R. This is known as triangle law of vector addition. Okay. Look here. Let a person moves from here and moves O to Q, then Q to P1. Then total displacement is from O to, actual displacement is from O to P1. Okay, then we have OP1 is equal to OQ vector plus QP1 vector. Am I right? Okay, then OQ vector plus QP1 vector is equal to OP1 vector. When a person moves from O to Q and Q to P1, then total actual displacement is from O to P1. Okay, that is OP1 is equal to OQ plus QP1 is equal to OP1. OQ plus QP1 is equal to OP1. Okay, OQ plus QP1 is equal to OP1. Yes. Then what is OQ? OQ is this length. And it is, what is the length of OQ? It is x. Okay, length of OQ means the magnitude of this vector xi. What is magnitude of vector xi? It is x. That is why OQ is x. Plus QP1. What is QP1? Okay, what is QP1? QP1 is equal to OS. QP1 is equal to OS. These are equal because they are the equal edges of the cuboid. That is why they are equal. Okay, then OQP1 is equal to OS. What is OS? It is Yj. Then we can write it as xi. OQ vector is, if it is vector, xi vector. Okay, if we want to find its magnitude, it is x. Okay, then OQ vector is equal to xi vector. We have similarly QP1 vector is equal to OS vector, which is equal to Yj. Then we can write it as Yj for QP1 because QP1 is equal to OS, OS is equal to Yj. So we can replace QP1 by Yj. Then let a person moves from O to P1 and P1 to P. Then what is the actual displacement? What is the actual displacement? The actual displacement is from O to P. Okay, then we can write OP is equal to, OP vector is equal to endana OP1 plus P1P. OP1 plus P1P. Okay, which is equal to OP1 എന്താ ഓൾറെഡി കണ്ടെത്തിയിട്ടുണ്ടല്ലേ? OP1 ഇവിടെ കണ്ടെത്തിയിട്ടുണ്ട് അല്ലേ? ഓൾറെഡി കണ്ടെത്തിയിട്ടുണ്ട് xi plus yj ആണ് OP1. Okay, then we can write it as xi plus yj. Okay, plus what is P1P? P1P is this length, which is equal to this length. And what about this length? This is set k. What is this? This is set k vector. Okay, that is set k vector. That is, we can write P1P is equal to OR vector, which is equal to set k vector. So we can write set k vector instead of P1P vector. Okay, P1P vector, that is set k vector. So OP vector is equal to xi plus yj plus set k. What is OP vector? It is a position vector of point P. What is point P? The coordinate of the point P is x, y, z. Then what is the position vector OP? Position vector of OP is equal to xi plus yj plus z k. So if we are given a point, we can find the position vector. If we are provided with the position vector, then we can decide the point. Okay, here let this point is 2, 3, 4. Then what is position vector? Position vector OP is given by 2i plus 3j plus 4k. Okay, got it? Okay. Then there is a question. Find the magnitude of the vector phi a, where a is equal to 2i plus 3j plus 7k. Okay. A is given. What is a? 2i plus 3j plus 7k. Okay. The magnitude of vector phi a, that we have to find. Magnitude of phi a is equal to 5 into magnitude of a. 5 into magnitude of a. That is scalar multiple. Let lambda is a scalar. If lambda a vector magnitude is equal to lambda into magnitude of vector a. Okay. Upon here it is 5 into vector magnitude of vector a, which is equal to 5 into, what is magnitude of vector a? Magnitude of vector a is equal to root of 2 square plus 3 square plus 7 square, which is equal to root of 4 plus 9 plus 49. Okay. Which is equal to root 62. Okay. Then we can replace magnitude of a by root 62. What is the magnitude of phi a? 5 root 62. Okay, here it is 62. Okay. 5 into root 62. 5 into root 62, first option is correct. Okay. Then we have already studied the position vector. Position vector is a fixed vector which locates a point with respect to another point. Usually it is origin. Okay. What is collinear vector? The vectors which are parallel to same line irrespective of direction and magnitude is said to be collinear vectors. So what is collinear points? We have collinear points are the points on the same line. Let this is A, this is B and this is C. Then we can say A, B, C are collinear points because they are on same line. But what about collinear vectors? Collinear vectors are the not the vectors which are lying on same line. Okay, but they are parallel to same line. Okay, let this is a line and these two vectors are parallel to same line. That is why these vectors are said to be collinear vectors, irrespective of direction and magnitude. That is, if two vectors are collinear, then they are parallel to same line, irrespective of direction and magnitude. Here, these two vectors are in opposite direction, but they are parallel to same line. Okay, that is why they are collinear vectors. Similarly, they are on same direction, but parallel to same line. That is why they are called collinear vectors. Okay, if two vectors are collinear, there is a condition. What is it? If vector A and vector B are collinear, vector A is equal to lambda B vector, where lambda is a scalar. Okay, let A equal to 4i plus 6j plus 10k. B is equal to, B vector is equal to 2i plus 3j plus 5k. Then we can write vector A is equal to 2 into vector B. Am I right? 2 into 2, 4. 2 into 3, 6. 2 into 5, 10. That is why A vector is equal to 2B vector. Here lambda is equal to 2. That is why A and B are collinear vectors. If A and B are collinear vectors, then their scalar components are in ratio. Okay? Yes. Then A equal to 2B vector. We have 2 into 2, 4, 2 into 3, 6, 2 into 5, 10. That is A equal to 2B vector. Then lambda is equal to 2. Okay. Then if two vectors are collinear vectors, their scalar components are in ratio. Here 4 and 2 are in ratio, 4 by 2 is equal to 6 by 3 is equal to 10 by 5, which is equal to 2, which is equal to lambda. Okay. Then if two vectors are collinear, then how can we explain this collinearity? A equal to lambda B vector, where lambda is a scalar. That is collinear vector. Okay. Then here a question. If the points A is equal to 60i plus 3j and B is equal to 40i minus 8j, C is a point AI minus 52j are collinear, then A is equal to, then we have to find A. So these are the points. A is a point, which means it is a position vector of the point A is given, which is equal to vector A, that is a position vector of point A. Position vector of point A, vector A is given, that is 60i plus 3j. Similarly, position vector of B, okay, is given, which is 40i minus 8j. Okay, similarly, position vector of C is given, that is C vector is equal to AI minus 52j. Okay, then they are collinear. These points are collinear, and we have to find the value of A. These points are collinear, then we have to find the value of A. Okay, then what is AB vector? AB vector is the position vector of B minus position vector of A. Okay, position vector of B minus position vector of A. That is AB is a vector. How can we express a vector joining 2 points A and B? It is position vector of B minus position vector of A. Okay. What about CD vector? Position vector of D minus position vector of C. What about PQ vector? Position vector of Q minus position vector of P. Okay. Here AB vector, and so position vector of B minus position vector of A is AB vector. Then it is, what is B vector? 40i and A vector 60j. Then we can subtract B, we can subtract A from B. Okay, then 40i minus 60i minus 20i. B minus A. Okay, minus 8 minus 3j minus 11j. Okay, that is AB vector. Then what is BC vector? We have BC vector is position vector of C minus position vector of A. What is position vector of C? AI minus 52j. Then what is position vector of A? 60i plus 3j. Then C minus A, that is A minus 60. A minus 60i. Okay. Minus 52, C minus A, minus 52 BC. Okay, BC vector എങ്ങനെയാ? BC vector, 1 second. BC vector എന്താ? BC vector is equal to position vector of C minus position vector of B. Okay, then what is position vector A? C, position vector of C, AI minus 52j. Then A minus 40. A minus 40i. Minus 52 minus 52 minus minus 8, minus 52 minus minus 8, which is equal to minus 44, minus 44 j. Okay, then we have AB vector is equal to lambda BC vector. Okay, AB vector is equal to lambda BC vector. Okay, A minus 40i minus 44j is equal to lambda into BC vector. AB vector എന്താണ്? Sorry, AB vector ആണ്. We can write AB vector. Okay, we can write AB vector. AB vector is minus 20. AB vector is equal to lambda BC vector. Okay, then AB vector is equal to minus 20i minus 20i minus 11j equal to lambda into BC vector. BC vector is A minus 40i minus 44j. Okay. Then we have lambda into minus 44 lambda minus 44 lambda. lambda into minus 44, that is minus 44 lambda is equal to, here the scalar component of j is minus 11, which is equal to minus 11, which is equal to minus 11. Okay, then lambda is equal to minus 11 by minus 44 is equal to 1 by 4. Lambda is equal to 1 by 4. If lambda is equal to 1 by 4, what happened? We have minus 20 is the scalar component of I, minus 20 is a scalar component of I is equal to lambda into scalar component of I in the right hand side. Okay, because if two vectors are equal, their scalar components are equal. So A minus 40, A minus 40, A minus 40. Okay. Then lambda is minus 20, lambda is 1 by 4 into A minus 40. 4 into minus 2 minus 80 is equal to A minus 40. Okay. Then A equal to minus 80, minus 40 when moves from RHS to LHS, when it moves from LHS to RHS, it become plus 40. Then A equal to minus 40. Value of A equal to minus 40. Okay, value of A is equal to minus 40. Got it? Okay. Then different types of vectors: zero vector, vector having magnitude 0, unit vector having magnitude 1. We have already studied co-initial vector. What is co-initial vector? Let this is a vector A and this is vector B and have same initial point, then these vectors are said to be co-initial vectors. Collinear vectors we have already studied. What is the condition for two vectors to be collinear? Vector A is equal to lambda B vector. Okay, then equal vectors. What is equal vectors? If two vectors are equal, their direction and magnitude are also equal. Okay, magnitude and direction are both of them are equal, then such two vectors are equal. Then what is negative vectors? Let this is a vector and having magnitude A, let another vector is here having magnitude A, same magnitude but they are in opposite direction. Then these vectors are said to be opposite vectors, that is negative vectors. Okay, what is negative vectors? The vectors having same magnitude but are in opposite direction are said to be negative vectors. Okay. Then existence of identity, that is zero vector is identity element of addition. Okay, a vector A plus 0 is again we will get A. Okay, so 0 is the identity element. And associativity, A plus B plus C is equal to A plus B plus C. Vector addition is associative. Okay, similarly vector addition is commutative. A plus B is equal to B plus A if A and B are any two vectors. Similarly, there exists additive inverse. If there is a vector A, then there exists a vector minus A such that A plus minus A is equal to 0. Okay, we have already studied. What about AB vector? We have AB vector is the position vector of B, position vector of B minus position vector of A. Okay, position vector of B minus position vector of A. Then in how it is happened, we can check it. Okay, here it is O. Then we have triangle of vector addition. We have a person move from O to P1, then P1 to P2. Actual displacement is from O to P2. Actual displacement from O to P2. A person move from O to P1 and P1 to P2. Then actual displacement is from O to P2. Okay, then we can write OP1 plus P1 P2 is equal to OP2 vector. Then what is P1 P vector? P1 P vector is equal to OP2 vector minus OP1 vector. Look, what is OP2? OP2 is a position vector of OP2. This is O, this is P2. OP2 is a position vector of point P2. Why? Because it locates the point P2 with respect to origin. That is why OP2 is a position vector of P2. Look, position vector of P2 minus what is OP1? Position vector of P1. That is P1P is equal to P1P is P1 P2. This is P1 P2. Okay, P1 P2 is equal to position vector of P2 minus position vector of P1. Position vector of P2 minus position vector of P1. Similarly, what is position vector of AB? Position vector of B minus position vector of A. Okay. Then there is a question. In the cube of side A shown in the figure, direction vector from a point A to the point F will be. Okay, so we have to find this vector. Okay, A and this is F. AF vector. We have to find AF vector. Okay, we have to find AF vector. What is AF vector? How can we find AF vector? AF vector, position vector of F, position vector of F minus position vector of A vector. Okay. Then, E point and what is this point? This point is on y-axis and this length is A. Why? It is the cube with length A. So, this point is on y-axis. Its x coordinate is 0 and y coordinate is this length which is A and z coordinate is 0. This point is 0, A, 0. Similarly, what about A? Then A is A lies in a xz plane. Okay, then its x coordinate is this length, which is A. And what about it lies in xz plane, and so y coordinate is 0. Z coordinate is A. Okay. Then how can we find the position vector? If we got a point, the position vector is, what is position vector of F? Position vector of S is 0i plus aj plus 0k. What is position vector of A? Position vector of A is ai minus 0j, ai plus 0j plus ak. Okay. This is AF vector. And we have to find the direction vector along direction vector. What is direction vector? It is nothing. We have to find the unit vector along the direction of AF, which is known as direction vector of AF. Okay. First we have to find AF. Then what is AF? 0i minus AI minus AI. AJ minus 0j plus AJ. 0k minus AK minus AK. This is the vector AF. Then what is magnitude of AF? Magnitude of AF is given by root of minus A square plus minus A square, which is equal to root of 3A square, which is equal to A square plus A square plus A square, 3 roots, 3A square, okay, which is equal to root 3A. Okay, root 3A is the magnitude. Then we have to find the direction vector. What is direction vector? Direction vector means the vector along the direction of, unit vector along the direction of given vector, which is AF. Then what is AF? What is unit vector along the direction of AF? AF cap is equal to AF vector divided by magnitude of AF vector. Okay, which is equal to AF vector is minus AJ plus AJ minus AK. Okay, then what is magnitude of AF vector? We have already find it is root 3A. Okay, then what happened? 1 by root 3, A can be cancelled. Okay, A can be cancelled. Then we will get 1 by root 3 into minus j, minus I, okay, this is I, minus I plus j minus k. Okay, aj minus 0, aj positive j, 0, 0 a 0. Okay, position vector of f. Okay, minus a plus aj minus ak, correct. Okay, then minus a plus aj minus ak. Then root 3, 1 by root 3 into a can be cancelled, minus j minus I plus j minus k. Okay, minus I plus j, option ഇല്ല കേട്ടോ, ഓപ്ഷൻ ഇല്ല, അത് എഴുതിയപ്പോൾ തെറ്റിയത്. 1 by root 3 is equal to 1 by root 3 minus I plus j minus k is the answer. Okay, got it? Triangle of vector addition we have already studied. A person moves from O to P, then moves from P to Q. Then what is total displacement? It is from O to Q. Okay, that is A vector plus B vector is equal to R vector. R vector is equal to vector A plus vector B, which is triangle of vector addition. Okay. Then parallelogram law of vector addition. Similar to triangle of vector addition, here we have a parallelogram. Then OB is equal to AC, because these are the opposite sides of parallelogram. Opposite sides of parallelogram are equal and parallel. Okay, so what is direction of AC is similar to Q, which means OB vector is equal to AC vector, which is equal to Q vector, since OB is Q vector. Okay, then we have a person move from O to A, then A to C. Total actual displacement is from O to C. Okay, which means actual displacement is from O to C, which is represented by the vector R. Then we can write OA, that is P vector, plus AC, that is Q vector, is equal to actual displacement is from O to C, which is R vector. And this is known as parallelogram law of vector addition. That is, if we are given that two adjacent sides of a parallelogram, the diagonal of the parallelogram is the sum of that adjacent sides. Okay, which means the diagonal of a parallelogram is equal to sum of adjacent sides of the parallelogram. Okay. What is A dot B? A dot B is equal to AB cos theta. A dot B is equal to magnitude of A into magnitude of B into cos theta. What is theta? Theta is the angle between A and B. Okay, theta is the angle between A and B. Then what is A dot B? A dot B is equal to magnitude of A into magnitude of B into cos theta. Okay. What happens if A and B are perpendicular? We have, if A and B are perpendicular, A dot B is equal to magnitude of A into magnitude of B into cos 90. Why? Because theta is the angle between A and B. If A and B are perpendicular, the angle between them is 90 degrees. So theta is 90 degrees. Cos 90 is 0, which means A dot B is equal to 0. A dot B is equal to 0 if A and B are perpendicular. Similarly, magnitude of A dot B is equal to magnitude of A into magnitude of B if A and B are parallel vectors. Why? Because A dot B is equal to magnitude of A into magnitude of B into cos. If two vectors are parallel, what is the angle between them? It is 0. Then cos 0. That is 1, which is equal to magnitude of A into magnitude of B. Okay. Okay. Here there is vectors, vector. These are vectors. Okay. If theta is the angle between vectors A and B, then we have vector A dot B is equal to magnitude of A into magnitude of B into cos theta. Okay. Similarly, if theta is acute, cos theta is greater than 0. Why? If theta is acute, cos theta is greater than 0. We have theta acute, which means it lies either in first quadrant or lies in fourth quadrant. But cos theta is positive in first quadrant. If it is either in first quadrant or in fourth quadrant, cos theta is positive. Because we know that in fourth quadrant cos is positive, first quadrant all trigonometric ratios are positive. Okay, that is why what is A dot B? A dot B is equal to, let me have A dot B is equal to magnitude of A into magnitude of B into cos theta. Okay, then cos theta is positive because theta is acute and it lies either in first quadrant or fourth quadrant. Okay, so cos theta is positive. Magnitude of B is always positive. Magnitude of A is always positive, which means A dot B is positive, greater than 0. So if theta is the angle between A and B is acute, A dot B is greater than 0. Similarly, if the angle between them is obtuse, what happens? It can be lies in second quadrant or in fourth quadrant. Okay, it can be in second quadrant or it can be in, if it is clockwise direction, if it can be in third quadrant. Okay, in first, second quadrant and third quadrant cos is negative, then this become negative. Okay, which means A dot B become negative. So if theta is obtuse, cos theta is less than 0 and A dot B less than 0. Okay, we have, this is vector A and this is vector B. This is angle theta between A and B. Okay, and this angle, another angle is here, and this angle is said to be, it is alpha and is said to be reflex angle. And we take only the angle between 0 and 180 degree or 0, 180 when we consider the angle between A and B. Okay. Find the dot product of two vectors. Okay, there is a question. How can we find A dot B? A dot B is equal to magnitude of A into magnitude of B into cos theta. Okay, here magnitude of A is 9, magnitude of B is 5 root 2. Then theta cos 45 degree, which is equal to 1 by root 2. Root 2 can be cancelled, 45. Then 45 is the answer. Option A is correct. Okay. For the vectors, A equal to B is also given, A is also given, A plus B dot A minus B. What is A plus B? A plus B vector is equal to, we can add the scalar components, I plus I, 2I, J plus 2J, 3J, K plus 3K, 4K. Okay, this is A plus B. Then what is A minus B? A minus B is equal to I minus I, 0I, J minus 2J minus J, K minus 3K, J minus 2J minus J, K minus 3K minus 2K, K minus 3K minus 2K. This is A minus B. If a vector A is given, A1I plus A2J plus A3K, and vector B is equal to B1I plus B2J plus B3K, then A dot B is given by A1B1 plus A2B2 plus A3B3. If two vectors are given, the angle between them is not given. Angle between them is not given. So we can multiply the corresponding scalar components and then add. Then we will get dot product. Then 2 into 0 is equal to 0, 3 into minus 3 minus 3, 4 into minus 8 minus 8, then we will get minus 11. Minus 11 is the answer. Option 2 is correct. Okay, got it? What is A cross B? A cross B is equal to magnitude of A into magnitude of B into sine theta n cap, where n cap is a unit vector along the direction of both A and unit vector perpendicular to both A and B. Okay, it is a unit vector perpendicular to both A and B, which provides direction to A cross B. That is why the direction of A cross B is perpendicular to both A and B. Okay, result of cross product is a vector. Result of dot product is always a scalar. Okay. Then what is I dot I? I dot I is equal to magnitude of I into cos 0. That is magnitude of I1. This is 1, cos 0 1, 1. That is which is equal to j dot j, which is equal to k dot k. Okay. Then what is I dot j? I and j are perpendicular to each other. Then their dot product is 0. Like if a and b are perpendicular, a dot b is 0. Okay. Similarly, j dot k is 0. K dot I is 0. Okay. We have a dot b is equal to b dot a. That is dot product is scalar. We can dot product is commutative. A dot b is equal to b dot a. A dot b is equal to b dot a. Okay. But what about cross product? What about cross product? Cross product is not commutative. A cross b is equal to minus b cross a. It is not commutative. Okay. Then what is I cross I? I cross I is equal to magnitude of I into sine 0 n cap, because the angle between I and I is 0. Okay. Then this value is 0. Okay. That is I dot I is equal to j dot j is equal to k dot k is equal to 0. Then what about I dot j? We have if we find a cross product a cross b, we will get a vector which is perpendicular to both a and b. So here we must get a vector which is perpendicular to both I and j, which is k. Then what is j cross k? It is I. What is k cross I? It is j. Then what is j cross I? It is minus k. Then what is k cross j? It is minus I. Then what is I cross k? It is minus j. Because a cross b is equal to minus b cross. Okay. Got it? Here there is sum of properties. A dot a is equal to 0. Why? Because the angle between a and a is 0 and sine 0 is 0. That is why a cross a is 0. A cross b is equal to minus b cross a. Distributive. It is distributive. Cross product over addition is distributive. Okay. That is a cross b plus c is equal to a cross b plus a cross c. Okay. Similarly, we can move in between scalar in between cross product. Okay. That is L into a vector is equal to L a vector cross m b vector is equal to L m into a cross b. Okay, a cross b is 0. Therefore, a and b are collinear, which means if they are parallel, if a and b are parallel, then a cross b is equal to 0. Okay, these results we have already discussed. Okay, then how can we find a cross b if angle is not given? If angle is not given, let vector a is equal to a1i plus a2j plus a3k. Similarly, b vector is equal to b1i plus b2j plus b3k. Okay, then what is a cross b? A cross b is equal to ijk a1, a2, a3, b1, b2, b3. Okay, if we solve this determinant, we will get vector. Okay, the result of a cross product is always a vector. Result of dot product is always a scalar. Okay. Which one of the following is a unit vector perpendicular to A and B? Okay, we have the vector perpendicular to A and B is A cross B. Okay, A cross B is a vector perpendicular to both A and B. So we can find A cross B. A cross B is equal to, what is I, J, K? A is scalar components of I is minus 1, 1, 1. Scalar components of B is 1, minus 1, 1. Okay. Minus 1, 1, 1, 1, minus 1, 1. Okay, then I into I, the column is delete the column of I and row the row and column of I is deleted. Okay, then what will be determinant 1, 1, minus 1, 1, minus j into, we can delete the column and row of j. Okay, then minus 1, 1, 1, minus 1, 1, 1, 1. Okay, then plus k. Okay, we can delete the column of k and row of k. Okay, then we will get minus 1, 1, 1, minus 1. Okay, this is equal to 1 minus of minus 1, 2, 2i. Minus 1, minus 1, minus 2 plus 2j. Minus 1 into minus 1, 1, 1 minus 1, 0, then 0k. Okay, then you will get 2i plus 2j is the vector, which is perpendicular to both A and B. Okay, then we have to find the unit vector perpendicular to A and B. So we have to find the unit vector along the direction of this vector. How can we find it? First we have to find the magnitude of this vector, that is A cross B. Okay, magnitude of A cross B is equal to root of 2 square plus 2 square, which is equal to root of 8, which is equal to 2 root 2. Okay, 2 root 2. Sure. Okay, then A cross B cap is equal to A cross B divided by magnitude of A cross B. We are finding the unit vector along the direction of A cross B. Okay, then which is 2i plus 2j divided by 2 root 2, which is equal to 2 cancelled, 1 by root 2 into I plus j. 1 by root 2 into I plus j. This is correct. Okay. Projection of a vector A on B. Okay. What is projection of vector A on B? Projection of vector A on B is given by A dot B divided by magnitude of vector B. Okay, A dot B divided by magnitude of vector B. Let this is theta and this is vector A and this is vector B. Then what is cos theta? Cos theta is adjacent side, that is B vector, divided by adjacent side by hypotenuse, that is A vector. Okay, then B vector is equal to vector A cos theta. Okay, which is a projection of A on B. But vector B is equal to vector A cos theta. Okay, then let vector A cos theta. Vector B is equal to vector A cos theta. A dot B is equal to magnitude of A into magnitude of B into cos theta. Okay, magnitude of B into cos theta. Then what is magnitude of A? What is magnitude of B? Magnitude of B is equal to magnitude of A into cos theta. Okay, then we can write A dot B divided by magnitude of B is equal to magnitude of A into cos theta. Okay, here also magnitude of B is equal to magnitude of A into cos theta. Okay, then magnitude of A into magnitude of B cos theta, which means the projection of A on B is given by A dot B divided by magnitude of B. Okay, projection of A on B is given by A dot B divided by magnitude of B. Then there is a question. A and B, C, 3 points are given. Then projection of AB on AC, that we have to find. What is AC? AC vector. Projection of AC, AB on AC. We have to find AB on AC. So first we have to find AB. What is AB? 1 minus 0, 1, that is I. 1 minus 3, that is minus 2j. 1 minus minus 3 plus 4k. This is AB vector. Then what is AC vector? AC vector is equal to 2 minus 0, that is 2i. 0 minus 3 minus 3i, 3j. 3 minus 3, that is 6k. Okay, 3 minus 3, 6k. Okay, then projection of, we have to find projection of AB on AC. We have to find projection of AB on AC. What is it? AB vector dot AC vector divided by magnitude of AC vector, which is equal to AB vector എന്താ ഇതാണ്. അപ്പോൾ ഡോട്ട് പ്രോഡക്റ്റ് 1 into 2 2 minus 2 into 3 6 4 into 6 24 whole divided by magnitude of AC. This is AC. Then what is magnitude? Root of 2 square plus minus 3 square plus 6 square, which is equal to root of 4 plus 9 plus 36. Okay, which is equal to 49 is equal to 7. 7 is the magnitude. Okay, then you will get 7 here. 2 plus 6, 8, 8 plus 24, 32. 32 by 7. Yes, option B is 2 is correct, 32 by 7. Okay, let's move. Then what is vector projection? Vector projection is nothing. We have projection of A on B is equal to A dot B divided by magnitude of B. That is projection of A on B is given by A dot B divided by magnitude of B. Then what is vector projection of A on B, which is given by magnitude of A dot B divided by magnitude of B into B cap. Okay, so you have to find the projection and also you have to find B cap. We know that what is B cap? B cap is equal to B vector divided by magnitude of B. Okay, write down this. I think you can do it alone. Am I right? Okay, then continue. Here there is a picture. Let R is the point which divides the PQ in the ratio M is to N. This is M, this is N. Okay, R is the point which divides PQ in the ratio M is to N. Then what is the position vector? OR is the position vector of R. OR the position vector of point R. A is the OP is the position vector of point P, which is equal to A vector. And OQ is the position vector of Q, which is equal to B vector. Then position vector of point R is given by R vector is equal to M into B vector and N into A vector. Okay, MB vector plus NA vector divided by M plus N. So if we are provided the ratio at which a point divides a line having n points P and Q, which also the position vectors of these points are given, then the position vector of the point which divides that line in the ratio M is to N is given by R vector is equal to MB vector plus NA vector divided by M plus N. Okay, if the point Q divides, if the point R divides PQ externally, okay, then this length P, the length PR is M, and Rn is equal to N. Then what is position vector of R? Position vector of R is given by R vector is equal to position vector of OQ is B vector and position vector of OP is A vector. Okay, then which locates the point P and Q respectively, and OR is the position vector of R which locates the point R, which is equal to R vector. Then R vector is equal to MB vector minus NA vector divided by M minus N if the point R divides PQ externally. Okay, if the point R divides PQ externally. Okay. Then let A and B are adjacent sides of parallelogram. Then what is, let this is a parallelogram. Let this is B and this is A. We have this is H, let, and this is theta. Okay. Then what is the area of parallelogram, which is BH, and here base is this length. Let we can name it ABCD. Then BC, length of BC is the magnitude of vector B. Okay. Then vector B is B. Then what is H? H is this length. Okay. H is we have what is sine theta. Sine theta is equal to opposite side, that is H, by hypotenuse, that is magnitude of A, which is equal to H equal to magnitude of A into sine theta. Okay, we can substitute for H magnitude of A into sine theta. This is half, this is, what is this? This is, okay, B vector, and this is magnitude of A cross. Magnitude of A cross. So if A and B are adjacent sides of parallelogram, area of the parallelogram is given by magnitude of A cross B. Okay. Here triangle B is a side, B and C, B and A are the sides of adjacent sides of triangle, this triangle, and we have area of the parallelogram is A cross B. And then what about this area? Area of this triangle is what is it? Okay, what is that? This is H. We have H is equal to, when this is theta, H is equal to, we have sine theta is equal to H opposite side by H by hypotenuse. Hypotenuse is B. Okay, which is equal to H equal to magnitude of B into sine theta. Okay, then what is area of triangle? Half into BH. Okay, here B is vector A, magnitude of vector A. Then half into vector A, what is H? B, vector B sine theta, which is equal to half into magnitude of A cross B. This is the area of the triangle. If A and B are in adjacent sides of triangle, then area is given by half into magnitude of A cross B. Okay. This is a question which appeared in 2025 JEE mains. So A equal to I plus 2j plus K and B is given. Let C be the unit vector in the plane of the vectors A and B is perpendicular to A, then such a vector C is. Okay. Here it is given A and B and C are coplanar vectors. C be the unit vector in the plane of vector A and vector B, which means A and B, C are coplanar vectors. That is A cross B dot C is equal to 0 if A and B, C are coplanar vectors. Okay, so they are coplanar vectors. What is coplanar vectors? Lies in same plane. Okay, then it is unit vector. It is C is unit vector. Okay, C is unit vector and perpendicular to A, which means the dot product of A with C is 0. So first of all, this is unit vector, and this is not unit vector because 1 by root 5. This is also unit vector. This is also unit vector. This is also unit vector. Okay, all these vectors are unit vector. Then whether all these vectors are perpendicular to A, 1 by root 2 into 1 by root 2, minus 1 by root 2. 1 by root 2 into 1 by root 2 into 1 by root 1 by root 2 is equal to 0. Yes, this vector is perpendicular. And what about this vector? 1 by root 5 into 1 by root 5. K on minus 2 by root 5. 2 by root 5 into 1. Minus 2 by root 5 into 1. That is minus 2 by root 5. It is not equal to 0, which means this option this option cannot be possible. Then what about this I minus j plus k? This is 1 into 1, 1. 2 into minus 1, minus 2. 1 into 1 plus 1, which is equal to 0, can be. It can be. Okay, it can be. Similarly, 1 by root 3 into 1, 1 by root 3. Minus 1 by root 3 into 1 minus 1 by root 3. 1 by root 3 into 2 plus 2 by root 3. Okay, minus 1 by root 3 into 1, that is minus 1 by root 3 is equal to 0. It can also be possible. So what is A cross B? A cross B is equal to I J K 1 2 1 2 1 minus 1, which is equal to I into 2 minus 2 minus 1, that is minus 3i, minus 2 minus 1 minus 3i minus minus 1 minus 2 minus 3 plus 3j, okay, plus k into k 2 1 minus 4, that is minus 3k, 1 minus 4, that is minus 3k. Okay, so we have to check the dot product with A cross B is 0. Dot product of C with A cross B is 0. Okay, then we can check. We have A cross B dot C equal to 0. Why? Because A and B and C are coplanar. Okay, lies in same plane. So dot product, which of the vectors, if we do the dot product with A cross B is 0, that we can check. 1 by root 5. 1 by root 5 into minus 3 by root 5, minus 3 by root 5, minus 2 by root 5 into k, that is plus 6 by root 5. It is not equal to 0. It is not equal to 0, which means this can be cancelled. Then 1 by 3. 1 by 3 into minus 3 by root 3. Okay. Then minus 1 by 3 into minus 3 by root 3. Okay. Then 1 into 1 by root 3 into minus 3 by root 3, that is minus 3, that is minus 3 by root 3, not equal to 0. So this is not possible. Similarly, this is not possible, but this is only an option which is possible. Okay, let's check it. 1 by root 2 into minus 3. Minus 1 by root 2 into minus 3, that is 3 by root 2. Okay, then k. 1 by root 2 into minus 3, that is minus 3 by root 2, which is equal to 0, which means if we do dot product with this vector, dot product of this vector with this vector is 0, which means this is unit vector, and this is perpendicular to vector A, and this is also coplanar with A, B and C, A and B, which means option A is correct. Okay.